from backups or I guess reducing cluster load while adding nodes. So first of all, I'll just talk a little bit about who I am and what I do. As I said before, my name is Ben Bromhead. I'm the co-founder and CTO of Instaclustr. Instaclustr provides Cassandra as a service in the cloud. So really what that means is, we take care of provisioning, monitoring, periodic maintenance tasks, backups, all wrapped up in kind of 24/7 support. With really our end goal being that, your developers can kind of just spin up a cluster with us and they don't have to worry about managing it. They just kind of throw data at us and we take care of it for you. We're currently in Amazon Web Services. Google Cloud's currently in a private beta with some other providers to come as well. We currently manage around 50 nodes for various customers of various sizes, and they do various things with it. So Cassandra and Scaling. So we had the whole idea behind scaling Cassandra, right? And I'll kind of get down to basics a little bit. We have an existing cluster. We need to add more storage, better performance, high capacity. And so with Cassandra, this is all about scaling horizontally. And so that's adding additional nodes to your cluster. Normally this is a fairly awesome process. Most people do this, what they do, start up some new hardware, start up a new instance, configure up Cassandra, you set your seed nodes, start the process, the node joins the ring, takes responsibility for a portion of the ring, and then it begins the Bootstrap process. The joining node then streams data from existing nodes within the cluster, and it streams across the SS tables, it builds indexes, all that kind of thing. And as I just said before, specifically what happens is the existing nodes will send the SS table across the wire to the joining node, and this SS table that it sends, it's like the data component that it sends. It's not perfect, but it's getting better. Over the last couple of years, we've seen a few issues within the open source version and other bits and pieces where the Bootstrap process isn't as beautiful as you'd like it. Like it's quite a nice concept. It's a very simple idea, but it has a few kind of rough edge cases. Things like violating consistency due to range movements. Adding replacement nodes has also been a bit of a tricky thing. It's a slightly different workflow. You've got replace address. Adding nodes to a cluster with multiple racks can also be tricky and prone to creating hotspots. This is mainly an operational issue and you can get around it, but the recommendation is generally not to do it because sometimes it's a bit harder than the benefits that it brings. With Instaclustr, we actually do support racks, and we encourage you to use them because a lot of our back-end infrastructure around scaling is geared towards actually dealing with the way that Cassandra allocates, nodes to racks and doing it in a safe manner. Unfortunately, there's a bit of a fundamental flaw with this process. So joining nodes, they actually add additional load onto the existing cluster because what they've got to do, they've got to communicate with the other nodes and then stream data from them. So this increases the load on the disk, increases the amount of CPU and reading the tables, and then also just general network I/O. Typically, this is actually felt most in small clusters as well. So you're kind of looking at cluster sizes under 10 or 12. The bigger the cluster is, the easier it is for the cluster to absorb that additional load, and then each portion or each node in a much larger cluster only has to stream a smaller portion of data that it's responsible for. For most Cassandra users who kind of keep who experience linear growth and you keep an eye on it, this is kind of, you can manage it through capacity planning, figuring out when you're going to have a quiet time and you can kind of do it. Of course, there are pain points in the process and we wanted to really solve this for our customers and we wanted to essentially prevent, a situation like this. So some of the solutions that are, I guess, currently available is to make sure that your nodes never get stressed. So you're never in a situation where you need to add capacity while you've got a lot of load on your cluster. So an example of this, let's say you get featured by a current affair, you get a whole volume of users, you need additional capacity. You don't want to be adding nodes to your cluster during an event like this because it actually makes the problem worse. So really the solutions to this is, one, make sure your nodes never get stressed. And this isn't an unreasonable thing to say. What you can actually do, with a bit of capacity planning. DataStax Ops Center actually has some really good tools around that, about predicting load, about predicting CPU usage, that kind of thing. The other one is to also over-provision. This is probably one of the simpler options, but it's also quite expensive. The third option is to make sure that your project, your startup, your company never gets any traction whatsoever and nobody uses your service, because, it's easy that way. So what do we do if our nodes are already stressed? And we're kind of hitting the limits of our ability to kind of cope with things. What are some ways that are currently existing in Cassandra to kind of handle this? Most of the time you just kind of batten down the hatches and just wait for things to kind of go away. With solid and tested methodologies around that, and actually stressing your own infrastructure, usually this is actually a fairly alright thing to do, because Cassandra actually has built-in load shedding mechanisms, right? And if you've built your service to kind of handle that, to either drop consistency levels, or you're just happy to let a few requests, either 500 or timeout or whatever, you can get away with this. The next kind of solution to this is that you're a Cassandra wizard. You can jump in, you can start to kind of, tune it without restarting the nodes and that kind of thing. Eking out the last performance of a node without restarting it. Good luck, but, some people try to do it. The other kind of, Cassandra has a little bit of support for, bootstrapping from different locations, and this comes from the idea of multiple data centers. So if you've got two data centers, what you can actually do is, in the data center that is experiencing a bit of stress, you can actually add an additional node. What you do is you set Bootstrap to false. Once it's joined, you then run node tool rebuild against the other data center. It'll actually stream all the data from the other data center, assuming that's also not under stress as well. So there are a few options that you kind of have. Unfortunately, all these solutions, they've got various strengths and weaknesses. They either have side effects or they're relatively costly. So for example, with the other data center, quite a lot of our customers, they're actually small startups. They don't have the cash to kind of pay for another data center. Obviously there's some availability issues, but they like to rely on Amazon's availability zones. You can judge whether that's sane or not on your own. But for us as well, really, we still needed to address the fact that as a managed Cassandra service, we really need to make all our operations as side effect free as possible. And so what I mean by that is, when we get an API request and when we get a support call to add additional nodes to the cluster, we're dealing with customers that actually, they don't really want to know about the guts or the internals of Cassandra. They know that it's great for scalability, they know it's great for availability, but they just want it to work, right? So when we scale up, we want to make this as side effect free as possible, so that when they make that scaling call, their cluster doesn't fall over and they go, well, wait, I was just adding capacity. And this is where I'd like to introduce Bootstrap from backups. So I'll start off with a few facts. So SS tables are immutable. They're also the base unit of data that nodes stream to and from each other. SS tables are also what we back up. So everyone here does backups, right? No? I get it. Cassandra, it actually kind of has that built in. You've got your replication factor. You can kind of build it out to different data centers. But in the environment that we work with, particularly AWS, we find it's a very good idea to have backups. It's great from a disaster recovery point of view as well. But it also means if AWS suddenly yanks something from under our feet, we can react and recover from that. So how about we stream the SS tables from a backup location instead of a live node? And really, is such a thing possible? Yes, it is. So what we've done is we've actually kind of patched Cassandra 2.1 to kind of, intercept some things in some different places. So it's very similar to the way that commit log archiving works. If anyone's used that, that's where you define an arbitrary command in a properties file. That command will specify some tokens that Cassandra will then replace, that it'll then use to kind of identify which SS table it needs to get based on what node it's streaming from. So a good example here is cat mount, some NFS mount, the source node address. At the moment, we're doing this using broadcast addresses and then the file name of the SS table. So one of the things we've also had to do is modify the gossip protocol, sorry, not the gossip protocol, the streaming protocol, to actually send this information over the wire so we know what file name it's actually streaming from. Cassandra will then run the command in a separate process and read the SS table from the process's standard out stream. We don't know whether this is the best way to do it. This is just kind of what I did while trying to get this to work and see how feasible it is. I guess potentially a better solution would to maybe have some sort of pluggable API where you can drop your own jar in, specify the class, and then you can use whatever Java streams you want to do that's kind of best for your fit. If the process fails, the node will then just stream the SS table using the normal manner, so it'll then stream it from the existing nodes. So this is a cluster. It's got normal backups. We're pulling all the SS tables, into either a NAS or S3 or however you want. Your backups can kind of be however you want to do it, whether you snapshot weekly, whether you actually archive every single SS table using incremental backups. That's up to you. It all sort of depends on how much you want to pay for your backup costs and how much your data changes over time. And the normal Bootstrap procedure, SS table gets streamed to the new node, and this kind of occurs for all the nodes within the ring. Especially with, sorry, this is also kind of very applicable to vNodes. A lot of my examples here, it's all about vNodes. We run vNodes by default on everything that we start. It just makes operational procedures a lot simpler. So Bootstrap from backups, it looks kind of something like this. So instead of grabbing SS table 1 from node 2, we grab it from NAS or S3. And then we do that for all kind of SS tables that we need to grab using the new node. And then obviously if an SS table is not available in the backup, that's either because the backup process hasn't run or it hasn't synced any new data during the time. It then grabs that from the node. So what happens is it actually ends up grabbing about 80% of the data from your backup location, and then it kind of gets the diff in terms of the SS tables from the existing nodes. So how does it look in real life? So a bit of a disclaimer as well. We've really only done this in a lab environment. We actually haven't used something like this in Anger, and we've really just been testing it a little bit. So this is kind of what a cluster looks like. This is what we ran this using YCSB, just using mixed 50/50 synthetic benchmark, just on I think it was 3 M3 largest, so very, very small performance kind of AWS nodes, because we really wanted to restrict the environment that it was operating in to actually show you guys what was happening during the Bootstrap process. So around the 25-minute mark, that's when we added the new node. It bootstraps. You see a little bit of a dip in performance. This is what the cluster looks like on Bootstrap from backups. Unfortunately, my graphing skills aren't really that great. There is actually a slight drop because it still needs to kind of contact some of these other nodes and get the diffs from, but it's a much less, I guess, heavy operation. So really, that's kind of, I guess, the guts of what we've done. We're really looking to start to roll this out as we open up our API to support, scaling, because our API is currently private at the moment, but we will open it up so that our own customers can kind of just call add node, remove node, and then it's a very easy process. So really, the reason why this actually matters is it really makes Bootstrap a lot less it makes it a lot more side effect free. You can kind of start to do things like reactive scaling rather than predictive. There's a lot of kind of information out there and work and academic papers that has gone into trying to make a system as a whole, and this is not just Cassandra, make a system as a whole be predictable, be able to ramp up as usage increases. And so, having something that is slightly more reactive, it lets you kind of manage your costs around that a lot better, and it just makes your cluster in general a lot more cost effective to use to run. So when can I use this? Not right now. Like I said, we've currently only used it in the lab. We haven't even submitted a patch as part to the Cassandra project. We really wanted to use this opportunity to kind of, I guess, gauge community interest. So I guess the other thing is, we're not too sure about how much of a good idea this is to do using standard out as the streaming mechanism. We'll probably need to refactor stream message workflow because currently it's a bit of a hacks at the moment. But yeah, so we're pretty excited about it because it really makes our service really easy to use. But I think for the community as well, it'll give a lot of benefit and just being able to make scaling a little bit easier. So this is a nice and short presentation. I'd like to open up the floor to any questions.